So I'm here at KScope 13 with MariaColgan, who is the optimizer lady, and just got out of a session that she did on 12C and the optimizer in 12C. You mentioned that one of the big things about the database is what it's dealing with in terms of real time. A lot of the applications nowadays, there isn't a lot of time, and the workloads are changing almost continuously. So when you're doing reactive tuning, sometimes there's not enough time to do reactive tuning, and you need something that's a little bit more proactive. So what have you done that's different in 12C?
So in 12C, the optimizer has taken a big step forward, and it's becoming what we call adaptive query optimization. And what that allows us to do is delay the final plan decision until after parse and actually during execution. And we're doing that in 12.1 with the introduction of adaptive joins. Adaptive joins allow us to delay the join method decision until execution, until we actually see the number of rows that are going to flow into that join.
You mentioned something about how it's changed in terms of the first time that you pass through, you actually collect statistics on it, and then only you make the choice about which join plan you use, or...
Yes, so what you'll see in 12C plans is actually a new operation that is inserted above the table access on the left-hand side of a join. It's called a statistics collector. That statistics collector is going to buffer the rows until we get a good sense of how many rows are coming out of the left-hand side. It won't buffer all of them, but it will buffer up to a given threshold, and then we'll make the decision based on that threshold whether we continue with the original choice of plan. Let's assume that let's say it was a nested loops join, or whether we should switch and use a hash join instead. Once we've made that final decision, that new statistics collector becomes a pass-through operation. It no longer buffers rows, but allows them to flow through into the join.
So now, is that going to be a performance hit at all, or?
So this adaptation occurs just on the first execution. So it is possible that the initial execution of a SQL statement that may take advantage of adaptive joins would see a small degradation in performance due to that buffering while we make our decision, but all subsequent executions shouldn't see any problem because, as I said, that statistics collector is disabled. It becomes a pass-through operation, and the final plan that we decided during the initial execution will be used by all subsequent executions.
So in that case, it's actually better to take, even if it's a minor hit, because effectively you're not being committed to a choice of execution plan that maybe was based on bad statistics.
Exactly, that's suboptimal. That was based on a per set of statistics to begin with. By deferring it until execution time, although as you said, you take that small hit potentially on the initial execution, all subsequent executions will benefit from the knowledge that we learned.
Thanks. Now, the other thing you mentioned, it's calling dynamic statistics. And you said that it's being used a lot more extensively. Do you want to talk about that versus what people are used to? I think you called it dynamic sampling was what it used to be called.
So the second part of our adaptive query optimization is a dynamic or adaptive statistics. And dynamic statistics is the rename or the relaunch of dynamic sampling, which was what the feature was called up until 12C. And the reason why it got renamed is it got a complete facelift. Dynamic sampling has been extended to not only look after cardinality misestimates on a single table, but actually for joins, group bys, as well as those single table accesses or index accesses. And not only are we extending the number of times that dynamic sampling can kick in and be used, we're also sharing those results or storing those results in the cache so that subsequent SQL statements that use those same objects don't actually have to waste time gathering the dynamic statistics. They can benefit from the ones that were gathered on previous executions.
You mentioned the SQL plan directives. Now, those aren't the same as SQL tuning hits. What exactly purpose is that new introduction of those?
SQL plan directives is a mechanism that allows us to persist the information we learn during re-optimization. This is another arm or aspect of the new adaptive query optimization. Re-optimization means that we noticed on the first execution of a SQL statement that the actual number of rows being returned by each of the operations in the plan vary significantly from our original estimates. And so we've marked that statement for re-optimization. That means the next time the statement is executed, we're going to hard parse it again, and instead of using the base table statistics that have led us to per cardinality estimates, we're going to use the execution statistics we learned on the first execution. By applying those, we're able to come up with a better, more optimal execution plan, and whatever we did learn, we are storing as a SQL plan directive. That means it will be used by the SQL statement for future execution, so we don't have to do this re-optimization. But it can also be used by any other SQL statement that refers to the same objects that are being referred to in the SQL statement. So SQL plan directives are matched to SQL statements based on a SQL phrase and not a specific SQL ID or signature.
And so that is actually persisted in the database cache, and you can reuse it again. It's not aged out like the previous one.
Exactly. So it's not stored in the shared pool. The SQL plan directives are actually persisted in disk, or Oracle automatically records them and stores them in the sysocs table space so that they can be used not just by other SQL statements in this session or in this database instance, but if the database is shut down and restarted, those directives are persisted, they will be there, and we can use them in the future.
So obviously this is some major changes here. You hinted or alluded to, actually you straight out said it, that some people aren't going to be that happy with applying this straight out of the box. You did mention a report mode. I thought that was very interesting. Do you want to explain how that works?
Sure. So all of these features can be disabled. Obviously, as you said, not everybody embraces change as quickly as we'd like them to. So when people move to 12c, they're going to be concerned that all of these new features and functionalities will potentially lead to plan changes. And as you and I know, not every plan change is for the best. So there is a couple of things you can do. You can disable all of the features that we've just talked about with a single init.or parameter, or what you can do is just put these adaptive plans or these adaptive join methods into reporting mode. And by enabling it in reporting mode, which again is controlled by an init.or parameter, what we'll do is we'll continue to monitor the execution, but we won't change or adapt the plan during the execution. We'll stick with the original cost-based plan we came up with at PARS, but we'll record the execution statistics so that we can show you, when you ask us to display the report, what would have happened if we had been allowed to adapt. So if we notice that the number of rows coming out of the table on the left-hand side of the join is much greater or much less than we originally thought, and the join method should have changed, we'll tell you what we would have done if we'd been in adaptive mode, but we won't actually adapt the plan.
Oh, that's excellent. That's just like running that Linux command where you can say, okay, what's this going to do? And it actually shows you exactly what it's going to do, but it doesn't actually execute it.
Without actually executing it, yeah.
Perfect. Well, thanks very much, Maria. That's very educational, and we're looking forward to the optimizer in 12c.
Thanks.